Hello, my name is Ali Sekmen. I'm a professor of computer science at Tennessee State University. In this video, I'm going to introduce object-oriented programming concepts in Java. I'm going to explain what a class is, how you create objects from a class. I'm going to talk about static versus non-static, talk about the new keyword, and many other concepts. So it's extremely important that you fully understand everything discussed in this video before you proceed to the next video. I hope you have fun and enjoy it. Okay, let's get started. This is for Comp3110 Java Programming Language class at Tennessee State University, and this is Introduction to Classes. So let's talk about what's a class. It's extremely easy. The concept is very easy. Think about the Batman building in Nashville. That's the AT&T building. The question is, if we have the Batman building in Nashville, is it possible for us to have exactly the same replica of this building in Memphis or in another city like Atlanta or New York, Chicago, and so on? So what do I have to have in order to construct the exact copy of the Batman building in multiple cities? Of course, I just need the blueprint of the Batman building. Then I can use the same blueprint to construct the exact replica of the building. The blueprint itself is simply a class, and each building that I build in multiple cities is an object, okay? So think about this. We have the blueprint, and then I create or construct one building in Nashville, exactly the same building in Memphis, and exactly the same building in Atlanta. So the blueprint is the class, and each building is an object. So using the same blueprint, you can create as many objects you want, okay? So never confuse class and objects. They are not the same thing. Class is the blueprint or recipe that we use to create objects. Java is an object-oriented programming language, okay? And in this language, you can use predefined classes. So far, for example, we use system, string, scanner. And today we are going to use JOptionPane. You can use predefined classes, and you can create objects of predefined classes. If you recall, we created an object called scan using scanner class. Scanner class is a predefined class. It is developed by Java developers. And in order to create an object, we always use what? New keyword, as we'll get familiar. Or you can define your own class, and you can create your own objects. That's what we're gonna do today. Okay, so to get started, first let's talk about certain things that you need to get familiar. In a single Java file, in a single .java file, you can have multiple classes. It doesn't have to be just a single class. You can have multiple classes, but only one of them can be public. And the name of the public file, the name of the file must be the same as the name of the public class. It is important. Think about this example. Here I have a single text file in which I have 1, 2, 3, and 4 classes, and only one of them is public. You cannot make this one public if this is public. So you can have only one public class, and the rule is that the name of the file, test.java, must match to the name of the public class. Okay, so test.java needs to match. So what happens when I compile this? I go and compile with javac test.java. So far, we had single class file test, and we compiled Java created test.class for us. However, in this case, even though we have a single file, even though we compile a single file, Java is going to create 1, 2, 3, 4 class files for us. One class file or bytecode for each class that we have. So therefore, I have animal.class, car.class, student.class, and then test.class. I hope this is clear. I repeat, in a single file, you can have multiple classes. Only one of them can be public, and the name of the file must match to the name of the public class. Okay, and when we compile it, a separate .class file is generated for each class. Okay. Now, what if I call my class test2 but I name my file test.java. So basically the name of the file is not the same as the name of the public class. In this case, you're gonna get a compile error. When you try to compile Java C test.java, it will say that class test2 is public, should be declared in a file name test2.java. Okay, so this is the error that you're gonna get. So the name of the file must match to the name of the what? Public class. Okay, a class is a blueprint of a building. And you can construct as many buildings as you wish. Construct, build, create, instantiate, they are the same thing. Creating an object, building an object, instantiating a class, they are the same concepts, okay? So using the same blueprint, you can construct, build, create, instantiate as many buildings, in other words, as many objects as you wish. Every class must have at least one constructor, okay? A class may have methods. In some languages, in Java, we call it methods. In C++, we call them functions. When I say method or a function, they're exactly the same thing. So a class must have at least one constructor. They may have methods, and they may have data members. A class includes three things, I repeat. Data. So a class includes data. And then you have constructors so that you can initialize data. Initializing data means setting the state of your object, okay? The main task of a constructor is to initialize your data. And then we have methods that we can manipulate data. So we have data, constructors so that we can initialize data, and then methods or functions so that we can manipulate data, okay? So we are gonna see each one separately today. So let's focus on data first. Here is a very simple example. I have a class student, and class student has two things, name and ID. So name is type of string, ID is type of int. So class student has only data members and their name and ID, okay? So this is a very dummy example, but it has only name and ID. So how am I gonna go and create an object of this class? In order to create an object, I use new keyword, okay? So let's look at this. This is our app, Java application. This is our main method. Inside the main method, I'm gonna create an object. This is a single file named test.java. In that single file, I have two classes. One is test, which is public, that matches the name of the file. And then I have another one, student. Now, John is an object. And John is an object of student class. The type, John's type is student. With the new keyword, I allocate memory space. And then I say student parentheses. I'll explain what this parenthesis is and things like that very soon, okay? Once you do that, Java allocates memory space for you. In that memory space, it puts your data members, name and ID, and it initializes them to their default values. ID is int. Int is a primitive data type. Primitive data types are initialized to their default values, and the default value for int is 0. However, name is type of string. String is capital S. You see here, capital S means string is a class. In other words, name is a reference type or reference value, okay? So since this is a reference value, it is initialized to null. Null means nothing, simply. So I repeat this simple example. I have a single file, test.java. In that I have two classes, test and student. Test is public, and test says main method. In other words, when I compile and run the program, Java is gonna go and make a call to the main method right there. And inside the main method, the first line is student, okay? Student, that's the name of this class. And then a name, John. Object name starts with lower cases, therefore J is lowercase, by the way. It is so important that we use what? New keyword. And then I have student with parentheses right there, and I have semicolon. So let's see, we always use what? New keyword to create an object, okay? So what does this mean? John is a reference value, just like name. Name is a reference value. Why? Because string is what? A class. So this is a reference value. John is a reference value. Why? Because student with capital S, that's a class. However, ID is a primitive value, okay? And it contains the memory address. That points, John contains the memory address that points to a memory space in which I have space allocated for name and ID. Think simple. John is a reference that has memory address. It points somewhere in the memory in which I allocated memory space for my data members. In this case, they happen to be name and ID. Okay, how about this one? Now I have the same thing, but I did not use the new keyword. In this case, if you don't use new keyword, you do not allocate memory space. Okay, this is important that you realize this. And if I go and execute this line, John is a reference value, but it does not point anywhere in the memory. It is simply null. Okay, null means nothing. John does not point anywhere in the memory. Okay, so if you do not use new keyword, no space is allocated. That's what I'm trying to say. How about this one? Now, this is my blueprint, right? Class student is blueprint. And I told you that if I have the blueprint of the Batman building, I can create or build as many buildings as I want. Similarly, from a single blueprint, I can create as many objects as I want. So here I create an object called John, and then I create another object called David. Since I use new keyword for John, a memory space will be allocated for John. Similarly, another memory space will be allocated for David. Okay, here it is. This John points to a memory space in which I have name and ID, and they are initialized to their default values. For David, I have another memory space. So David is a reference type, a reference value that points somewhere in the memory, and I have allocated space for that particular object. Okay, well, let's see what we can do with this. Now, this is my blueprint class. I create student, I create an object of student class John. Then when I say John.name, so here is what happens. So let me see if I can do it here. John points somewhere in the memory, okay? And I have name first, it was null, and I had ID, it was 0. That's what I have in this line. Then when I say John.name John, this says that go to the memory space where John points to and change the variable name to John with double quotes. So it's going to go ahead and it's not null anymore, but it points, it is now John, okay? And then when I say John.id, go to the memory space where John points to and change ID to 230. In this case, this is not 0 anymore, it is 230. Then I go to this line, okay? It says create an object called David. It points somewhere in the memory. And here I have name. Name is initially null, and ID is initially 0. Similarly, when it says David.name David, go to the memory space where David points to, change name to David. So it is null anymore, but it is what? David. You see the double quotes because name is a string. Similarly, ID will be 545. I hope you understand this. So then that means John points to a memory space where name is John, ID is 230, and David points to a memory space where name is David and ID is 545. Okay? So well, is this good? I mean, look, every time I create a student, name is initialized to null, ID is initialized to 0. Is this good? I mean, it is actually very funny, right? And it doesn't make much sense. Is there any way that we can somehow, at the time that we create our object, we also initialize them to more meaningful values? We can define a constructor to do that, okay? So constructors are to initialize your data members. Look at this. Here, I have the same class, but this time I have something added to it. I have data members, name and ID, just before, as before. Now I have something, student. It's exactly like this. You see that? The same name as the class. I have parentheses, just like we do in methods. And I have two input arguments, string n, int I. And what does this do is, it gets n and assign it to name. It gets I and it assigns that to ID. Pay attention, there is no return value. It's not like methods. Methods have void and things like that. It doesn't have any return value. So what happens here is that if I go to the first line, right there, okay, it will say, let's create an object called John. John will point somewhere in the memory, for sure. In the memory, we will have name and we will have ID. But when I do create, this time, instead of just parentheses, I have two inputs. The first one is what? John. The first one is this one. And the second one is an int. So Java is going to say, well, I need to call a constructor that takes a string as input and an int as an input. Do I have such a constructor? Yes, I do. It takes a string as input and int as an input. So then it's going to make a call to this. N will be John. I will be what? 230. And inside this, N will be assigned to what? Name. Therefore, name will be John. And inside, again, I will be assigned to ID. And that means ID will be 230. I hope this is clear. And similarly, when I have the second object, David, I allocate memory space for David. In the memory space, I will have only the data members ID and name. And then this time, I make a call to constructor that takes a string and int. And I do have it, that means N is David, I is what? 45. Therefore, name will change to David, and ID will change to 545. Okay, I hope this is clear. John is pointing to a memory space where we have name is John, ID 230. Similarly, David points to another memory space, name is David, ID is 545. Okay, it's very easy. I mean, don't get intimidated with object-oriented programming. I mean, how difficult can it be anyway? So you just have a blueprint and use that blueprint to do things. Here's another one. Okay, so assume that you don't have any constructor. You still have one constructor because a class has at least one constructor, whether you explicitly define it or Java is gonna do it for you implicitly, okay? But you may have more than one constructor. You don't have to be, you're not limited to have one constructor because there may be multiple ways to initialize your data. You don't have to stick with only a single way. And the constructors have the same name as your class. For example, the constructor previously I had student. The name of the class was student. Constructor is also named student. And they don't have any return type, even void. So constructors do not have any return types. And if you have a constructor that does not have any input arguments, we call it the default constructor. If your class does not have any constructor, Java will make it. Java is going to assign a default constructor for you, and it will not do anything. I repeat, you can have multiple constructors, but let's assume you don't have any constructors explicitly. You said, I'm not going to define any constructor. In that case, Java is going to do it for you. But if you have at least one constructor, whether it is default or not, Java is not going to create any constructor for you. We'll see an example. If we have multiple constructors in a class, they are called overloaded constructors. This is important. Please get familiar with this keyword, overloaded constructors. Later, we're going to see we have overloaded methods. That means in a single class, you can have multiple constructors, and they are called overloaded constructors. And all the constructors must have the same name as the class. Again, the constructor that does not have any input arguments is called default constructor. So the purpose of constructors is to initialize the initial state of the objects. In other words, for example, I said John, name was John, ID was 230, right? 235. So that's the initial state of that object John, okay? Again, constructor name must be the same as class name. Constructors cannot have a return value. Constructors can only be called via the new keyword. So that's the only way to call a constructor directly. You have to have the new keyword. This is a part you will not understand at this point, but I want you to, just hang with me and try to mimic this one. Constructors may have modifiers. They can be public, protected, private, or none. But constructors cannot have modifiers. You don't know what abstract is yet, but they cannot be abstract, static, final, native, or synchronized. This is something I just want to mention for the listeners who already know those concepts from another programming language maybe, but let's skip this. Here is a simple example. I have student, class student. I have data members right there. I have 1, 2, 3, and 4 constructors in this case. The first one does not have any input arguments. That's called the default constructor. So our default constructor is this one. And then second one takes a string as input. The third one takes an int as an input. The fourth one takes a string and an int as input. So if I want to go and create a student, an object like this, student S1 new student. See the new keyword? That means I'm allocating memory space. So S1 will point somewhere in the memory. I will have name and ID. But which constructor do I call? Default. So it will go to the default constructor here. Name will be Ali, ID will be 10. Okay. How about this way? If I say student S2 is equal to new Alexis, well, now double quotes, that means that's a string. Java will say, okay, I need to create an object of student class using a constructor, using the constructor that takes a string as input. Do I have such a constructor? Yes, right there, right? So S2 will point somewhere in the memory, and pay attention here, Alexis will be sent right there. So N is Alexis. And therefore, and then N is assigned to name. So I'm gonna go to the memory space where S2 points to, and I will change the name in that memory space to N. That means name will be Alexis. Then I will go to the memory space where S2 points to, and ID will be in that memory space 10. How about this one? This time I have S3 new student 645. That's an int. So Java is going to say, okay, do I have a constructor that takes an int as input? Boom, right there. Therefore, this 645 is I, okay? And then I is assigned to ID. So S3 points to memory space in which I have name and ID, and name is Ali, and ID is 645. And finally, I create an object using another constructor that takes a string and an int as input. And I do have such a constructor, string and int. In this case, John will be there. This will be here. And N will be assigned to name. I will be assigned to ID. So I'm going to point the memory space in which name will be John. ID will be 230. Again, this one is default constructor. Why? Because there's no input arguments. Pay attention, I don't have any return values here, even void. Constructors have the same name, student, 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 student. They may have different parameters because we have different ways to initialize objects, and they don't have any return types. Okay, so this is actually how I had it in a single file. I have a file called test.java. Okay, when I compile this, I will compile as Java C test.java, and Java will produce two files for me. One is test.class, the other one is student.class. Okay, and when I run, I will run with Java test. I'm gonna run the one that has what? The main method. If I try to run Java student, this will give you an error because student class is not runnable. First, that's not public. Second, it doesn't have the main method. So only test class is the one that you can run. Okay. Well, so this is kind of inefficient, right? I mean, you put all the classes in a single file. Do we have to do that way? Obviously not. I mean, we don't have to keep. We can separate them. For example, in the previous example, I can have one file called test.java that contains my main method, and then I can have another file called student.java, and that contains the student class, okay? Now, let's assume that we place test.java and student.java on the same folder, okay? We place them on the same folder. In other words, this is my folder, and here I have test.java as one file, and second file is what? Student.java. Okay? They're in the same folder. And then I only compile, I go ahead and compile, I say Java C test.java. Well, Java is smart in the sense that when I compile test.java, it compiles, but within test.java, in the main method, I have student space John is equal to new something something. So Java will say, okay, I'm in the test.java. However, this person wants to create an object of student class. Do I have such a file? I mean, do I have such a class in the same file? No. Then it will look for a file named student.java. If there is a file named student.java in the same folder, it will also compile that one for you implicitly. And then it will create student.class file for you. Okay. However, if they are not in the same folder, then this is a little tricky. Okay, I'm going to put it here. This is one folder. You have test.java. This is one folder. And then you have another folder where you have student.java. So if you go ahead and compile Java C test.java, this is going to be an error because it's going to compile test.java. Within test.java, you have a reference to student class. And in the same folder, you don't have student.java. Java has no clue where student.java might be. So to solve this, first you go and compile this one. First you go and compile this one. I think I made a mistake maybe in the previous one. Of course, you can compile, but you cannot run. You cannot run student class, okay? So you are gonna go and compile first this, Java C student.java, okay? And you're gonna get student.class file. And then you're gonna move the student.class file in the same folder as test.java. Then you compile test.java, you will be fine, okay? Here is the example. Now I separated them, test.java, student.java, okay? I'm gonna place them in the same folder, just like maybe example3 folder. Then if I have ls, list them, I will see student.java, test.java. I'm compiling Java C test.java, okay? Once I list the files again, this time, instead of just Java files, I will say what? Class files. So Java automatically did the compilation of student class for me because I'm using student class right here in the test, and it looks for student.java and compiles that one for me. I repeat, among those files, only test is runnable, student is not runnable. In other words, if you go and type Java test, this is okay, but if you type Java student, this is an error because student class does not have the main method, okay? Okay, some easy but important concepts. If a class does not have any explicit constructors, Java will add a dummy default constructor for you. For example, look at this. My class student. It has only data members. It does not have an explicit constructor, but Java will add it for me. Java is going to go and add this dummy constructor for me. Default constructor, okay? Therefore, when I go and create an object S1, you see that I did with student parentheses. Well, this means I'm making a call to constructor. Why? Because you remember that with the new keyword, we can call the constructor, and I'm calling the default constructor. If you look here, even though you don't see any default constructor, in fact, there is one. Java created one for me. Does it do anything? No. But do I get an error? No, because I do have an implicit default constructor. Okay. Okay, very good. So that new student parentheses calls default constructor. Well, this is okay. Even though there is no explicit default constructor, Java adds a default constructor for us in this case. Okay, but this is important. Now, I have class student, no explicit default constructor. However, there is one other constructor. In this case, Java does not create a default constructor for you. You see that I already have a constructor, which takes a string and int as input. In this case, is this a default constructor? No. But do I have at least one constructor? Yes. In this case, Java will not create a default constructor for me. And then when I try to create an object using this one, I will get an error. Why? Java will try to call the default constructor. Well, student class does not have a default constructor, but since it has at least one constructor, Java doesn't create one default constructor either, so that's going to be a compile error. You see, you have to be really careful. And this tells us that it's always a good idea that you create your own default constructor. That's a good practice because you never know if Java will create a default constructor for you or not, especially when you have a large program, you cannot keep track of your constructors. So always put a default constructor for yourself. Don't expect Java to create one for you. So far, what did we discuss? We discussed data members. So a class has data, and then like name and ID, for example. And we discussed constructors. We may have multiple overloaded constructors. The main purpose of a constructor is to initialize data. Okay, so we have our data, we initialize it, then what do we do with it? I mean, we have to have some way to manipulate them, right? This is what we have as methods. Again, a class has data members, a class has constructors to initialize data members, and then a class has methods that manipulate data members. Again, methods and functions are the same thing. Here is a simple example. And now this is really good because I have my data, I have a constructor, then I have a method here. So pay attention, constructors do not have any return values or return types, but this is a method. By the way, constructors have exactly the same name, capital S, capital S. This is a method which does something, it will do something, but it will not return any value. So this is a method that doesn't take any input arguments, that doesn't return anything. All it does is it prints It says student name, and then whatever name it is, student ID, whatever ID it is. Let's just simply displace that. Let's look at this. Okay, with this line, I create an object called S that points somewhere in the memory. In this memory space, I have name and I have ID. Always construct this small diagram for yourself. It's a good practice. Then which constructor do I call? A string and an int, right? So a string and an int. So this will be n, this will be I. And n will be assigned to name, I will be assigned to ID. In other words, name will be what? John, as before. Okay, and then ID will be 230, right? Then I say s.display. I am making a call to display method. You see that? Display is a method of student class, and I call display with an object of student class. Okay, so what it does is, it says print. First it goes and prints what? Let's write it. It's gonna print student name, and then it's gonna print, it's gonna get name. Which name? Go to the memory space where S points to, get name, and concatenate it to this one. So it is going to go and say name is John. And then it's gonna go and say student ID, and then it's gonna print ID, but which ID? Go to the memory space where S points to, get ID, okay? And then it's gonna say 230. That's what it does here. We compile, we run, and it says student name John, student ID colon 230. I hope this is clear. So this is a method, a very simple method. It manipulates data. It gets your data and displays it. Okay. So this is how we define method. Every method must have a name, method name. Methods may have input arguments. Okay. In the previous method, we didn't have any input arguments. They must have a return type, and they must have a body. Methods must have a return type. If a method performs something but does not return a value, then we put void here, okay? Main method returns void, right? Because main method does something, it doesn't return a value. And common convention is that method names start with lowercase, like display that started with lowercase d. But if you have multiple words, the first one starts lowercase, the next one and the other starts with what? Capital letters. Let's talk about this right here. Okay, don't get intimidated. This is a very simple program. I created a class called myMath class, which has a data member pi, whose type is double. It is initialized to 3.14. It has a method called add. The name of the method is add. Return type is int. Input arguments are int. Input argument types are int and int. Input argument variables or values are x and y. What it does, it takes two input arguments, add them up, and return the result. You see, add method did return something. In the display method, we didn't use the return keyword because it just displays something but didn't return any value. However, add method takes two input arguments as input, and then it adds them up and returns. Then I have another one called area circle, which returns double. It takes a double input argument. So basically it returns the area of a circle. It is pi r square, right? Area, and then pi, and then radius, that means radius square. So let's see what's happening here, step by step. Let's understand fully. When I compile and run, this is the first line. So I'm going to have num1, num2, and sum. Okay? And then radius, RAD, and area. So these are my variables, okay? Then I created a scanner object and I say enter 2 integers. So on the screen, it will say enter 2 integers. And cursor stays here. Assume I enter 5 and then 12, okay? And here, next int will read the first integer and assign it to num1, and the second integer will be read by this and assigned to num2. In other words, num1 will be 5, num2 will be 12. I hope you're with me. And then it will say, I'm gonna go here, enter the radius. So it's gonna say, enter the radius. Cursor is here. Assume I enter 4.5. Okay, I'm making it up. And then next double method of scan, next double method of scanner class is gonna read whatever I type here as a double and put it what? Radius. So this one will have 4.5. Okay, I hope you're with me. Then here I create an object of my class. Here I'm gonna go and create, I will call it OBJ. That means it points somewhere in the memory. See, primitive data types, I use boxes. For objects, I use circle. And here, I'm going to have one data member called pi. So this will have pi as 3.14, okay? Then I make a call to add method via OBJ, okay? And I said num1, num2. So what was num1? It was 5. What is num2? 12. So I'm gonna make a call to add method right here. And I will send 5 here. I will send 12 right here. So what is x plus 5? X is 5, y is 12, x plus y is gonna be 17, and it's gonna return 17. Whenever it is returned, it is going to be assigned to sum. So sum will have, in this case, 17. Okay? It is nothing complicated here. Then I make a call to area circle and I send radius as input. What was radius? Here it is 4.5, right? So 4.5 will be sent here. So it's gonna return 3.14 times 4.5 times 4.5, whatever it is. Okay, so let's say it is 4, 16, 348. I am making it up. Let's say it is 56. I'm just making it up. So, and it's going to return 56 as double, and it will be assigned to area. So area is going to be 56. Then I will come to this line. It will say the sum of BAM. It's this person is signed D. It will go after comma and get the first one, num1, which is 5. And another person signed D, go to the second one after comma, num2, which is 12. And then is, and then another person signed D, go get the last one this time. It's going to say 17. Then I go to this line. It says the area of the circle with radius. Now, person is signed F, right? That's F. That means that's a double number. And I'm going to have only one digit after comma. After that, I already have that. It's gonna put 4.5. Okay, is, and then I have another one. I will put area 56.0. Okay, so here is another example. Like here, I compile, I run, I say enter 2 integers. In this case, I enter 5 and 23. Enter the radius, I enter 6. it adds 5 and 23, and it then finds the area of a circle whose radius is 6. Okay? I hope this is clear. Well, now, very important concept. I mean, but easy. So I want you to understand static versus non-static. Think about this class. And here, what I have pi. Pi is initialized to 314, right? So assume I create 3 objects of this class. I created the first object, obj1. obj1 points somewhere in the memory space in which I have a pi. obj2 points another memory space in which I have a pi 2. obj3 points to a memory space, I have another pi. Well, I know pi doesn't change. I mean, it doesn't make any sense that I have 3 copies of pi. For every object that I create, I have a copy of pi. So this is not a good approach, okay? So every time we create an object, we create a copy of pi, and it makes no sense. We only need what? 1 copy. And the solution is we can make pi a static variable, just like here. See, I define pi as static. In this case, what happens is, even though if I have 3 objects, I will have a single copy of pi. obj1 will refer to the same pi. obj2 will refer to the same pi. obj3 will refer to the same pi. In fact, even if I don't have any objects that created, that pi will exist. As soon as your class is loaded, even if you don't create any objects of my math class, that pi will exist in the memory. In the previous example, when it wasn't static, when your class is loaded, it will wait until an object is created, okay? So that's what a static is. With static data members, you have only 1 copy, whether you have an object or not. Whether you have 10 objects, 20, it doesn't matter. No matter how many objects you have, you only have a single copy, always. Okay? No matter how many objects we have, we always have a single copy of pi. Even if there is no object, we still have a copy of pi. So, non-static variables are associated with objects. So let's say that you have 3 objects, you have 3 copies of those non-static variables. Since they are associated with objects, and an object and instance are the same thing. By the way, when I say object of a class is the same as instance of a class. So instance and objects. Since non-static data members are associated with objects, we sometimes call them instance variables, okay? However, static variables are associated with classes. As I said, no matter how many objects you have, you will only have single copy. They are not associated with objects. And therefore, static variables are sometimes called class variables, okay? Just to emphasize, non-static variables are instance variables. Static variables are called class variables, okay? Let's see a better example, or a different example, not better, but different. Let's have a dummy class. I have 2 non-static members, x and y, and 1 static member, z. They are all integer. X is initialized to 10, y is initialized to 20, z is initialized to 30. They are all integers, okay? Now, I'm gonna create 3 objects. Object 1, object 2, object 3. When I create object 1, obj1 points somewhere in the memory. I have x and y, and they are initialized to 10 and 20. obj2 points to another memory space. Again, I have x and y as 10 and 20. obj3 points to another memory space. I have x and y, 10 and 20. I have copies of what? Non-static data members. If I have 3 objects, I have 3 copies. If I have 5 objects, I have 5 copies. However, objects do not have copies of z, as you see here. We have a single copy of z, 30. No matter how many objects that I create, I only have a single copy of z. Therefore, I say dummy class has a single copy of z. However, dummy class, every object has their own copies of x and y. Okay? So my question to you is this right now. Assume that I say obj1.x is 25. Is this okay? This is okay because with this statement, I'm saying that go to the memory space where obj1 points to and change the value of x to 25. So I'm going to go to this memory space and x will change to 25. There is no confusion, nothing. Or if I go and say obj3.y is 100. Well, I'm going to go to memory space where obj3 points to and change y to 100. Then this will change to 100. Still, there is no confusion. So that means it's okay to refer non-static variables like x, y via object names, right? There is no confusion. So that means non-static can be, I can have object name, then non-static variable name. This is perfectly okay because since I have a copy for each object and I refer them with object name, there is no confusion. When I say obj2.x, I know for sure that I refer to this x. obj1.y, that's definitely this y. There is no confusion. So non-static data members can be referred with what? Object names. However, if I go and say this, how about if I say, dummy class dot x is 500. Now, is there a problem with this? Yes, because I refer to x via dummy class, but there are 3 copies of x's. Java is going to get confused. I don't know which x that you meant to refer, right? So this is not going to be possible, okay? So in other words, non-static data members, x, for example, this can only be referred with object names. They cannot be referred with class names, okay? So I write it here, non-static only with object names. Okay, I hope this is clear to you. Okay, now let's talk the other way. How about this time I say, oops, let's have this one, dummy class dot z is 100. Is this okay? Yeah, that's okay. There's no confusion. There's only one copy of z. That means I want to go and change this z to 100. So this is perfectly okay. Now, what about this? What if I say obj2.z is 200? Is this a problem? Seems to be a problem, but it is not. There is no confusion. Whether I say obj2, whether I say obj1.z, obj3.z, doesn't matter because there is a single copy of z. There is no way that Java is going to get confused. In other words, whether you refer with class name or object names, that's perfectly okay. So non-static, since there's only a single copy, since there's no confusion at all, you can refer to them with what? Sorry, static object names or class names. Okay, so that's perfectly okay. This is important conversation. You have to feel very comfortable with it. I repeat, when you have non-static data members, every object will have its own copy. And if you refer to them via objects, there's no problem. But since we have multiple copies, if you refer them with the class name, there will be a confusion. Java will not know which one to refer. However, for static, there's a single copy. Whether you refer them with an object name or a class name, doesn't matter. Java will not get confused, okay? So this is, here is, let's see, this is another way of looking at it. Again, just as I explained, I create obj1, and x is 55. When I say obj1.x 55, this is okay. Why? Because I'm going to go to the memory space where obj1 points to, change x to 55. There is no confusion. That's definitely this x. Similarly, obj1.y, go to the memory space where obj1 points to, change y to 67. This is okay because this is definitely this x. Similarly, obj2.x is 32. I go to the memory space where obj2 points to and change x to 32. I didn't change y. Y is still 20. obj3.x 44. Go to the memory space where obj3 points to, change x to 44. And I say dummy class.x 88. Well, that's the problem because x, I have this 1, 2, I have 3 copies. When I say dummy class.x, I don't know which x that I'm trying to refer. So this will be what? An error. You cannot do that. You cannot refer non-static data members via class names. Okay. So yes, the non-static members right here can only be referred with object names. How about this one? Well, this is very similar to the previous one. So I have obj1, x is 10, y is 20, obj2, 10, 20, 10, 20. Now I say dummy class.z 50. Well, z is static, that means I have a single copy, and this will be perfectly okay. Okay, so this is going to change this z to 50. Okay, and then obj1.z 60. Is this okay? Yes, even though this is an object, this is a class, since there is a single copy of z, when I say obj1.z 60, this will change to 60. obj2.z 70, and then obj3.z is 80. This will become 80. So there's no problem. Since there's only a single copy of z, Java does not get confused no matter how you refer to z. Static variables can be referred with object names or class names. Okay. Similarly, we can have static methods as well. I mean, look, these are static data members. You can have a method. Method can be non-static or method can be static. Okay. The same way, everything is the same. For example, let's look at this. I create an object, obj. In this memory space, I have x, 10, y, 20, okay? And then I have a single copy of z. This is dummy class. Has a z, which is what? 30, okay? So now, is this okay? obj.x 100. This is okay. Why? Because x is non-static, and non-static can be referred with object names. Similarly, method 1 is non-static. Non-static methods can be referred with object names. This is fine. How about this one? Dummy class.x 100. Well, this is an error because non-static members cannot be referred with class names. Similarly, method 1 is non-static, and you cannot call a non-static method with class name. That's an error. How about this one? obj.z. Z is static, and statics can be referred with object names, no problem. Or statics can be referred with class name, no problem. This method 2 is static. I can refer to method 2 with what? Class name, no problem. Okay? So static versus non-static, that's important. Now let's have some fun. JOptionPane Class. So far, all the programs that we wrote, we compile on the terminal or terminal app or command prompt app, and we did run them on the same terminal or command prompt. Well, this is not very good, right? I mean, you want to have more sophisticated stuff. You want to have a message box and, you know, maybe some fun stuff. JOptionPane is for that purpose, okay? JOptionPane is located in Java X.Swing package. If you recall, if a package starts with Java X, that's an extension package. So that wasn't originally included in the original version of Java. So since Java X.Swing is not the default package, if you want to use JOptionPane class, you have to explicitly import it, of course. It has many static methods. Since they are static methods, I can call them with the class name. For example, I can say JOptionPane dot show message dialog. Okay, for example, I write it here. I can say JOptionPane dot show message dialog. Why? Because I know that this is a static method, and static methods can be called with what? Class names. Okay, so we are going to see some important methods like show message dialog, show input dialog, and some others in this class. Yep, I already did it here. I can call show message dialog right here, just like this. Okay, here is a very simple example. I import javax.swing.jOptionPane, and I have public class test, and then I have the main method. Now I say JOptionPane show message dialog. Show message dialog takes two input arguments. And the first one is, don't worry about it, just put null, comma, and then we have a string between double quotes. So when you do that, it's going to show a message box, and it will say, hello, TSU students. Okay? Or I can utilize show input dialog. Show message dialog shows, the return type of show message dialog is void. It just does something. But the return type of show input dialog is a string. Okay, so when you do JOptionPane show input dialog, enter your name, it's going to show this box for you. It will have enter your name here. You can type anything that you want there. Assume I type Ali Sekmen, and I type Ali Sekmen right here. It will be taken as this string. And then I use show message dialog. I say null, and then I say hello, and name Ali Sekmen will be concatenated to hello. It says hello, comma, Ali Sekmen. Okay, maybe I should go ahead and show you some examples. Okay. All right, so this is my screen. Let's go ahead and bring off our text edit. Text edit here. Okay. Also, I just want to remind you how you write your program, and then let's bring our terminal app. Okay. Here is my terminal app. It's right here. Let's make them reasonable sizes. Okay. And we said that we need to work in a, okay. And this is my folder, learning folder that I'm going to work with. I'm going to just delete whatever I had before. So this is my learning folder. And again, this is tilde. That means I am the user folder. If I say ls, I see all the subfolders. First, I go to my desktop. And ls, as you see, the learning folder is there. I say cd learning. So now I am there. This is command line interface. I am in this folder. And this is graphical interface. I am also in the same folder. So I'm going to go ahead and write my program. Says this is our program together. Just some commands. I'm going to import javax.swing.jOptionPane. Of course, there's a, okay, and then public class, let's say test. Okay, and public class, sorry, public static void main string args. Okay. And then I say JOptionPane dot show message dialog. Okay, null. I hope you are enjoying the class. Okay. All right, so this is all I have. And I'm going to save it under desktop, learning folder, the name of the file, as you know by now, is test.java. And I go here, you see test.java is right there. If I say ls, test.java is there. And I will say, let's clear the screen first, and I will say java c test.java. Okay, so what's the error here? Of course, I made a silly mistake. All right, maybe there are some other mistakes that you can see, I don't. Okay, JOptionPane, show message. Of course, here. You see, that's the nice thing about this text editor. You have to see all the mistakes that you do. That's why it's nice to stay in this. So it compiles. As soon as it's compiled, I have test.class. I say ls, I have test.class. Now I'm gonna run it with Java test, and it shows me right here a message dialog, okay? So I want you to be very closely paying attention. I click OK. It takes for a while. Did you see that it took for a while for the terminal to come back to the original location? There's a reason for this. I will explain a little bit later, okay? But pay attention to that. So let's modify our program. Let's say, okay, let's say string name JOptionPane dot show input dialog, enter your name. So show input dialog returns a string. So it's going to show a message dialog. I will input dialog. I will type my name, and then my name will be saved or stored in name. And then I will say hello name. Let's go ahead and compile this and then run it. It says enter your name. Let's say John dot, and it says hello John. Now look at this. Look at here, the cursor right there, and look, I click on OK and I wait. It took like some time, right, to cursor come back. How about if I go and add a line here, system.exit 0. I mean, I will explain what this is when I go back to the lecture notes in a minute. And now I save it. I compile again, run again. I say John dot. Okay. So now it is very quick. You see that? It didn't wait that long. So I wanted to keep this in mind until I added system.exit. When I click OK, it took for a while for it to terminate the program. However, when I put system.exit with 0 input, it was quicker to terminate the program. Okay. So I'm going to, now I'm going to go back to the presentation, and then we are going to continue. All right, so let's go ahead and continue. This is exactly the example that I did type there, and it says enter your name. I type my name, and then it says hello, Ali Segment. Again, when I click OK, it took for a while for the terminal, for the program to terminate. Okay, so here, even after you click OK in the message box, it takes for a while for Java to exit the program. And now the question is, I already show you how to fix it. You put system.exit, but I'll explain why. So why is this happening? This is important. So we are going to have a little informal introduction of multi-threaded programming, which is very nice, really. So here is what happens. When you run a Java application that has a GUI component, such as a message box, such as a button, and things like that, Java will have 2 lines of execution, one for the main method, one for the GUI. The line of execution for the main method, I call it main thread. the line of execution for graphical user interface, I call it GUI thread. Okay? When you are done with the main method, Java is going to automatically terminate the main thread, but Java will not automatically terminate the GUI thread. Okay? Therefore, it's stuck a little bit. However, if you use system.exit, it will kill all the threads. Here is the visualization of it. Think about this. This is a program without any GUI components in it. There is no GUI, no graphical interface. In this line, Java is going to have one line of execution, and that's going to call main thread. And as soon as I'm done with the main method, I will start here. As soon as I'm done with the main method, Java is going to terminate or kill this main thread, and everything is fine. So far, that's exactly what we did. Okay? But if you have this program has JOptionPane. That means this has a graphical user interface component in it. That means there are two lines of executions. And the first line is the main thread. And as soon as I'm done with the main method, this thread will be killed. Okay? This will be killed. However, even though I'm done with the main method, the other one will not be killed immediately. Therefore, we were stuck for a while, which is not good, right? So, but if you do the same thing here, if we add system.exit, even though we have two threads, main thread and GUI thread, even though main thread will terminate when the main method is done, Java, whenever system.exit, Java, whenever it sees the system.exit, it kills all the threads, whether GUI or not. So your program will terminate immediately. So system.exit. Now my question to you is, by looking at it, can you tell me if exit is a static method or not? Obviously, exit is a method of system class. Exit is a static method. How do I know? Because I'm calling it with class name. If a method is called with class name, remember, if you don't remember, go back a couple of minutes in the video. If a method is called via a class, that must be a static method. Similarly, show message dialog is a static method. How do I know? Because I'm calling with the class name. Well, okay, so I'm going to pause the video a little bit, and then I'm going to bring up my screen for you. Okay, so we are back. In this example, I want to write an example that will show a message box and ask the user to enter two numbers. It will take the first number, it will get the second number, and then add them up and show the summation of those two numbers to the user. Okay, so let's see. First, I will define int num1, num2, sum, because these are the going to be my inputs. So, well, okay, let's try to start from scratch by explaining to you. Assume I do this. Num1 is equal to JOptionPane show input dialog. Okay, enter an integer. Assume that I do that. Okay, and then let's put system.exit to the very end. System.exit 0. Well, let's see if this is going to work. Let's see if this is going to compile. And if it is not going to compile, why not? Let's see it. But this is supposed to show an input dialog, and then it should say enter an integer, and whatever I type should be saved or put in num1, right? Let's clear for the sake of visualization. Now I say Java C test.java, and then I get an error message. What does it say? It says that show input dialog returns string and cannot be converted to int. Because here, when you show an input dialog, Java doesn't know if you're going to type an integer. Java doesn't know you're going to type a string, or you can't type hello, right? So whatever you type is going to be stored as a string. Show input dialog returns a string. So therefore, you should define string, okay, maybe str num1, str num2. Okay, this is important. Now str num1. So now let's go ahead and compile. It compiles because show input dialog will return, even though if I put an integer there, it will be taken as a string. Similarly, I'm gonna go and ask for second integer. Okay, show enter first integer and second integer and this one. Okay, well, I did take them, right? No compile error, hopefully. Now I'm gonna do this. Sum is equal to str num1 plus str num2. Can I do that? Obviously I cannot. Why? Because this is string. This is a string. I cannot add two strings as numbers, right? So now I need to, before I do that, I can do num1 here, num2 here. But in order to do that, first, I need to somehow, I need to convert str num1 to int. Do you agree? So that, and I can save it as what? Num1. In order to do that, I'm going to use another method from integer class, parse int, and str num1. Okay, now we see another thing. First of all, parse int is a method of integer class. An integer class is located in java.lang package. Therefore, I don't have to import java.lang package to use it. Just like string class comes from where? It comes from java.lang package. System class comes from what? Java.lang package. Integer class also comes from java.lang package. And it has a static method. How do I know this is static method? Because I'm calling it with the class name. If a method is called with the class name, it must be static. It takes a string as input and it converts it to integer if it is convertible, okay? So with this line, I take whatever the user typed, I take it as string, and with this line, I convert it to an integer. Similarly, I'm gonna do exactly the same thing for num2, string num2. So now it's perfectly okay to say sum is equal to num plus num1 plus num2, okay? Then I can say JOptionPane dot show message dialog, okay? And now I say the first one is null, the second one is the sum, okay, is, I'm making the life easy, sum. Let's compile this and let's run it. Let's type it, Java test. Okay, here, enter first integer, 34. So str1, str num1 will be 34 as string between double quotes. And then I say enter second integer, 45. Again, str num1 will be a string, and num1, num2 will be integers, and it will say the sum is 79. Okay, and it exits pretty fast. So I hope you understand here. There are concepts, important concepts. First, I imported JOptionPane. Why? Because JOptionPane is not in the default package. JOptionPane is located in javax.swing package, so I imported it. Then I have class string, I have class integer, and I have class system. They are located in java.lang package. And exit is a static method. I know it because I'm calling with the class name. Show message dialog is a static method. I know it because I'm calling with class name. Show input dialog is a static method because I'm calling with the class name. parseInt is a static method because I'm calling it class name. Okay, so I'm gonna see you in a bit. Okay, so let's see. This was the program, or very similar to this one. Again, we imported this and so on. Instead of strnum1, strnum2, I probably clearly use first and second here. Okay, so I say enter the first number, enter the second number, the sum is 50. So, well, I can make it shorter, a lot shorter actually, you know. How? Let's look at this. If I show this, show input dialog, enter first number, I know as a fact that whatever the user types is gonna be a string. For example, if I type 20, this will be 20. Then I don't want to save it to somewhere, or I don't want to assign it to somewhere, because I know the only time I will need is just to use it. And with parseInt, I automatically convert 20. So this becomes number 20. Similarly, second, I enter 30, and it automatically converts it to right here to 30, okay? And then you can say the sum is, you add num1, num2, 20 plus 30, 50. But if you don't have those parentheses, be careful. It's going to print this one. The sum is, it's not going to print 50, okay? In fact, maybe I should show you this. Okay, so as you see here, what I am doing is I'm just copying this right here and replacing this one. And then I copy right here and I replace it with this one. So I can get rid of those altogether now. Let's see, let's go ahead and compile and run. I say 20, I say 30, and the sum is 50. Well, another thing that I can get rid of is the sum. I can just say num1 plus num2. Then I can get rid of this, and I can get rid of sum. Let's see. Okay. I type some number, another number, the sum is there. But what if I remove this? What if I remove this? Let's see what's gonna happen. Okay. I type 20, I type 30, it prints 20, 30, because first it converts number 1 to string, num2 to string, and add them up as string. Adding up a string is concatenating them, okay? So make sure that you have your parentheses here. Another question that I have in this example, what if I don't type an integer? What if I type something else? And you need to tell me what you expect. For example, I go in here, I type hello instead of a number. In this case, your program is gonna crash. Why? Because you take hello right here, and you try to convert hello to integer with parseInt. But hello is not convertible to an int, so your program is gonna throw an exception. It will say, I cannot. It's number format exception, okay? So these are little but important concepts. All right, so this is what I just showed you. So my question is, now I think we can answer those questions. As I told you at the beginning, we are gonna connect the dots. We are gonna in such a way that everything will be 100% clear in your mind. There will not be any question marks, but slowly. So my question is, why is the main method static? We have public, static, void, main, right? Why is the main method static? For example, I compile, I say java.test, then I run java test. So what happens here is that when you compile and you run Java, you see, I'm just running my class test. I have not created any object of test class. I'm just running the class. I'm just calling the class, and class makes a call to the main method, right? But since I'm just calling the class test or running the class test without any objects, I don't have no objects of test class. Yet I'm able to call the main method. So if I'm able to call the main method without any objects, it must be a static method because only static methods can be called with classes. Remember, if main method was non-static, I would have to have an object of test class to call it because non-static members can only be called with what? Object names. However, here, Java test, I'm just calling the main method without having any objects yet. Therefore, unless main method is static, I cannot make that call. Okay, this says when we run, Java automatically calls main method even though we don't have any objects of test class yet. Okay, if the main method was non-static, we would have to have an object of test class. Since Java calls main method without an object, it must be static. I hope now you understand why main method is static. Okay, I repeat, public static void main. It is void, we understand clearly because it doesn't have anything to return. It does something, it does not return anything. So return type is void. It is static because main method is automatically called when you run your Java app. Running Java app means loading your class test. When you load your class test, you don't have any objects yet. But yet you are able to call the main method. If you are able to call the main method without any objects, it must be static because only static methods can be called with classes without any objects. So this is another question. Can we call a non-static method from a static method? For example, look at this. I have a static method, public static void main, and I have another method void display, okay, display. But display is non-static, right? It's a non-static method. So my question to you, can I call display method right here, there? This will be an error. Why? If we have some reasoning, you can tell me that in order to call the main method, no object is needed. Why? Because that's static, right? So in order to call the main method, you don't need any object of test class, of course, because main belongs to what? Test class. But in order to call the main method, you don't need any object or objects of test class. However, if you look here, display is non-static. So that means in order to call display, you need an object of test class. Why? Because it is non-static. Non-static can only be called via objects. Then this is a contradiction because you start and run the main method, or you call the main method without any object. You go inside the main method, you need to call something that requires an object, but you don't have any object. So therefore, Java will not allow you to call a non-static method from a static method directly. Okay, so when you compile, it says non-static method display cannot be referenced from a static context, which is the main method in this case. So in order to call static main method, we do not need an object. However, in order to call non-static display, we need an object. If main can call display, then this may require that display is called without an object. That's a contradiction. So how do we fix it? I mean, it's easy. There are like two ways to do it. First, I mean, obviously I can make display static as well. Then I can call static. This is main is static, display static. I can call a static method from another static method, no problem. Well, but this is not a very good solution because there might be reasons that you want to keep display as non-static. In this case, this is what you're going to do. First, you go and create an object of what class? Test class. Why? because display is a method of what? Test class. So I say test, obj new test. I create an object of myself. Then I make a call to display via that object. Now I solve the issue. So first I created an object of myself, test, and then I call display method, which is non-static, via that object. That's an easy solution. Access identifiers. I'm going to talk about access identifier. This is very important, but I'm not going to fully talk about it because I'm going to talk about them fully when we discuss inheritance, subclasses, superclasses, and packages. We haven't discussed the packages formally yet. I just say javax.swing is a package, but you don't know how to create your own packages yet, right? So once we understand all those creating packages, understanding the inheritance and so on, we'll have a full conversation about it. But now I want you to understand with some partial conversation. Access identifiers can be public. Public is one extreme, private is another extreme. If we have private data members, for example, they are only accessible within the class that they are defined. They are not accessible outside the class at all. This is the most restrictive access identifier, okay? If there is no access identifier in front of an identifier, for example, when we had class student, we had string name and int ID, they didn't have any access identifier there. That means they are accessible from the same package. That means another class in the same package is able to access to those access identifiers. Protected, we'll talk about this later. Protected is accessible from the same package or subclasses. You don't know the subclasses concept yet. Public is least restrictive. It's accessible from any class. So what does it mean? I mean, I know that may not mean much unless I show you an example. Think about this. I have class A. When I put package edu.tnstate.cs, that means we will see it probably in the next video how to create a package, okay? In the next upcoming videos, I'm not sure next or the one after next. So here I have class A and I place it in a package called edu.tnstate.cs, edu.tnstate.cs. So class A is in a package. It has a private data member, non-protected data member, and public data member, okay? And assume that I have another class, class B, and class B is not in the same package as class A. In other words, in order to use class A, first I import the package that's in. Remember, in order to use swing, I did import javax.swing. That's JOptionPane. In order to use scanner, we have to import java.util.scanner. Similarly, assume class A is in this package, and I import that package edu.tnstate.cs.class A. Class B can use class A now, even though class A is not in the same package. And what it does is it creates an object of class A. Okay, it creates an object of class A. So I have obj, I created an object of class A, and here I have X, I have Y, I have Z, I have W. So obj points somewhere in the memory. Now, when I say obj.x, well, X is private. That means it is not accessible outside class A. Therefore, you are going to get an error here. obj.y, well, there is none. None means that's package access. In other words, class B, if class B was in the same package as class A, it could have access to it. But since class A and class B are not in the same package, this is not accessible either. And Z, protected means whether accessible from the same package or from subclasses. We don't know subclasses concept yet, but you know that class B is not in the same package as class A, and it is not accessible. How about W? W will be perfectly okay because W is public. Even though they are not in the same package, this would be okay. Public is accessible from anywhere. Here is another example. This time, assume class A and class B are in the same package. You see here, I have the package. That means class A is in this package. class B is in the same package as well, okay? Now let's see which one will work, which one will not work. So now I create an object of class A, obj. I have X, Y, Z, W. Now, this is private. Whether in the same package or not, you cannot access to it. So that's definitely an error, okay? And how about W? W is public, right? This is always okay. You can access to it. And this is none. None means package access. In other words, if class A and class B are in the same package, Y will be what? Accessible. And Z is protected. Protected is either package access or subclasses. Since they are in the same package, this will be fine. Okay? So private is least and most restrictive. Then we have none, and then protected, and then we have public. I hope you understand this to some extent. Okay, how about this one, this example? We have class A, okay? In class A, I have X, Y, Z, W, and I have a method within class A. So anything within class A is accessible, even if it is private. See, X is private, but X is in class A, method is in class A, so this is okay. Obviously, the rest are also okay. When two .class files, when you have two class files, and if they are located in the same folder, for example, let's say that I have this folder, okay? I have car.class and then animal.class, compiled files. If they're in the same folder, they are considered in the same package, okay? Even though you don't explicitly create a package and place them, if they're in the same folder, they are called in the same package, default package, okay? So if you have none as access identifier, we will not have any problem. So what do I mean by this? Look at this. I have, in this example, oops, I think if I can go back, here you go. Okay. So look here, I have none, right, for string, yet I am able to access to it. Why? Because test and student were placed in the same folder and they are in the same package. If two classes are in the same package, even though if it is none here, none is accessible, okay? Therefore, I was able to do name. But if I do name private, this will be an error. John.name will be an error. Some good object-oriented programming common practices. We should hide our data. I mean, if you make your data visible and changeable by users of your program, you might be in trouble. So you typically make your data private and you give controlled access to your data, okay? So when you make them private, no one can mess up your data without your control. But you make your data private and somehow give a way for the users to modify your data or access to your data. This is how we do it in good object-oriented programming. I have class student. Name and ID are my data members. I make them private. You see that? So that means name and ID directly accessible only within class student. I have my constructor here. However, I still want the user to be able to change name. I still want them to change ID, but to some reasonable things. For example, I don't want ID to be negative. If a user wants to change the ID to a negative number, I say, no, you can make max 0. For example, here, setID is a method. SetID is a method that I define, which takes an integer and it returns nothing. It takes an integer, it returns nothing. What it does, it checks the integer input. If it is bigger than 0, it assigns that to ID. If it is not bigger than 0, it assigns ID to what? 0. For example, if you try to make -100, it's going to change ID to 0. If you want to make 150, it will change ID to 150. And this is public because it is accessible by anybody. And similarly, I have get ID. Get ID, it just returns ID because when ID is private, you cannot access to it. But when you say get ID, you can, it's going to return an int, the same data type as this ID, okay? So set method returns nothing. It takes the same input type as your data. Get ID does not take any input argument, but it returns the same type as your data. Similarly, I have set name. For example, if you want to set a name that has 120 characters, I don't want that happen. I want to say the length can be maximum 50, okay, for the 50. So here, set name takes a string, which is the same type as name, and it returns nothing, and it checks. Later, you're going to see that length is a method of string class. If I say n.length, it returns the length of the string. If it is less than 50, I'm okay. Then that string is allowable as input. But if it is bigger than 50, then I say that name is invalid. And similarly, I have get name. Let's see with an example. Look here. First, I create an object called as right here, and it has name and it has ID. And which constructor do I use? I use this constructor. Therefore, John is this one, 500 is this one, and n is assigned to name, I is assigned to ID. Therefore, name is John, and ID is 500. Okay? Now, when I say s.id 56, well, this is an error. Why? Because ID is private. Test cannot access private data members of students directly. So this will be an error. Similarly, this is an error too. Why? Because I made my data private. So user cannot directly access to what? My data. So those two lines will be error. However, here, the user makes a call to set ID. Set ID is public. That means that's perfectly okay. A class can make a call to public method of another class. And it sends, what does it send? -100 as input. So that means I is what? -100. Is it bigger than 0? No. Then ID will be set to what? 0. Okay. So that means this ID is set to 0. Then I make a call again to set ID, this time with 200. So I is 200. 200 is bigger than 0, so ID will be 200. This becomes 200. Okay. Then I make a call to set name with what? David. So this is David. Set name here. N is what? David. What is the length of David? It's 5 characters, right? D-A-V-I-D, that's 5. So 5 is less than 50. 5 is less than 50. So name will be N, which is David. So this will change to what? David. Okay. So if I go and try to print s.id, well, ID is private. I cannot print it. So I will get an error here. However, if I say get ID is public. And get ID simply returns ID. The same int, this returns ID. This will be okay. However, when I say s.name, that's an error. Why? Because name is private. However, if I say get name method right there, this is perfectly okay. Get name, because that's public, and it returns name. What name? Go to the memory space where s points to. Get the name, which is David, and return it. So it prints David. Okay. Okay, how about constructor? Look, here This is private, this is private, public, 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 right? So how about constructor? I mean, our constructor is not, there is none. That constructor, if it is none, is only accessible from the same package, right? I mean, a student class, another class within the same package will be able to create an object of student class. Is that good? Probably not. And probably you want to make it also public, okay? So from now on, we are going to try to keep data private, constructors public, and depending on the method, most of the methods will be public, but sometimes we have utility methods. That means a method that I just want to use as a utility method within that class only. I don't want that method to be accessible to somebody else. It may be called making an intermediate computation for you, for example, to be used somewhere else in your class. Then you can make that private. Okay, so here are some examples. Let's just to refresh our memory. And let's look at this. Chevy is a class. It has only one method called toString, which doesn't take any input arguments, and it returns a string. Actually, it returns, this class does not have any explicit constructor. That returns a string. So basically, Chevy is a class. And now my question to you, does it have any default constructor, Chevy? It does not. When a class does not have any default constructor, what does Java do? Java creates a default constructor for you. So Java is going to go and place this one for you right here. It's going to put Chevy left and right braces. So even though Chevy does not have an explicit constructor, it still has a constructor, okay? And therefore, when I create an object of Chevy class, I will be just fine, okay? Because this default constructor, this will call the default constructor Java created for you. Is it gonna do anything? No. And how about when I make a call to obj1.toString? It's gonna go to the memory space where obj points to, and it's gonna make a call to toString method via that object. And it will say this class does not have any explicit constructor. So there is no error there. But if the user has defined any constructor, Java does not explicitly assign a default constructor. For example, this one. Let's look at it. This one has an explicit constructor here. Is that a default constructor? No, because it has an input parameter. Is Java gonna create a default constructor for us? No. Why? Because I have at least one constructor. So then it means I'm gonna get a problem here, because when I create obj1, I am making a call to the default constructor. So does Chevy have a default constructor? No. Therefore, that's gonna be an error, okay? Be careful. You should put your default constructor by yourself. How about this one? Let's look at this. I have city, I have a constructor, I have a default constructor, I have another constructor. So I have two constructors. They are overloaded. Remember, if we have multiple constructors, we call them overloaded constructors. So in this case, this will be perfectly okay. Why? I am creating an object using a constructor that takes a string as input. Do I have such a constructor? Yes. So this will make a call to this constructor. In this one, I am making a call to default constructor city. Do I have a default constructor? Yes. And this will make a call to this one. No problem. How about this one? Does it have any constructor? No. Then therefore, Java is going to go and create a default constructor for us. It will be something like this. It will not do anything. And therefore, this will be okay, because when I make a call to this, it will go and call that. However, let's look at this. Now we have a problem, because I have a constructor, and then when I try to call default constructor, it's going to try to call default constructor. It will go here. Well, do I have a default constructor? No. Is Java going to create one for me? No, because I already have one constructor. So that's a compile error. Okay, how about this? This will be fine, because food does not have any constructor. So Java is going to go and create a constructor for you, foot, left and right braces, and when you make a call, it will be okay. However, here, it already has a constructor. When you try to make a call to default constructor, Java doesn't have a default constructor there for you implicitly, and you will get a compile error because you already have one constructor. Let's look at this. Be careful. This has int. That means, yes, the name is test, capital T, but this has a return type. That means this is not a constructor, not a constructor. It is a method. Interestingly, you can have a method with the same name as your class name. Therefore, when you do this, it's not going to print anything. Why? Because it is not calling this one. It is calling the default constructor, which doesn't do anything. Java creates a default constructor for you. It doesn't do anything. This is tricky. Now, this reference, I want you to carefully listen this portion, because this is a reference to yourself. If you are an object with this, you refer to yourself. Let's see what it means. Let me show you the uses of this first. You can call another constructor within one constructor. Let's look at this. Okay. So I have a class test, which has a default constructor and which has two input argument constructors. So within test, if I say this 5.3, default constructor makes a call to the other constructor. Okay. So if you want one constructor to call another constructor, you can use this keyword. Okay. And we are going to see this with an example right here. Okay. So assume that I create this object, robot, obj, new robot. I made this one up, so don't be intimidated. It is a simple thing. So here I allocate memory space for obj. Here, what are my data members? X, Y, height, radius, right? So I'm going to have, obviously, I'm going to have X, Y, height, and radius. Okay, now let's see. Okay, and what am I doing? I'm calling the default constructor, right? I'm going to make a call to default constructor. That means I'm going to call this one. So here, this one makes a call to the default constructor. I'll go to this line, and this makes a call to this constructor here. Why? Because this is 20, this is 10. So 20 will be here, 10 will be right here. Okay. Now, there's a confusion here because my input arguments are called height and radius, but also my object has height and radius right there. Okay. So that's a problem. So first of all, let me put this one default value 0, 0, 0, 0 right there. In order to distinguish this height from this height, you use this. When you say this dot height, it refers, first of all, who is calling this constructor here? Obj is calling this constructor, right? Obj is calling robot. That means the caller of this constructor is obj. And the caller of this constructor is obj. When you say this dot height, it refers to the height of the caller of this constructor, height of obj. So 20 is here. This is 20. This is 10. And I'm going to assign 20 to the height of what? This obj. Why? Because the caller of this constructor robot is obj. So therefore, this is going to go and change to 20. Similarly, radius, this is radius, but there is differences because this is 10, I'm gonna go to the memory space where the color of this robot points to. The color of this constructor is obj. I'll go to that memory space and change that radius to what? Sorry, this was not that one. Height was 20, and this is 10. Okay, so this refers to obj in this case, basically. And again, if you want to distinguish this x from this x, okay, let's assume that I don't have this here. Assume I don't have this. Assume I don't have this. In this case, this means height is equal to height. There's confusion here. This is 20. I am assigning 20 to 20. Nothing is happening. So I'm not changing this height there. Okay. So this reference is used for two purposes. In this example, first, make sure that you can call another constructor. Second, you distinguish input argument from the data member if they have the same names. Okay, this is a very simple example. Similarly, you see I have type year VIN for object car, but set data is a method. It also has type year VIN. So in order to distinguish this type from this type, I use this reference. From this year, that means I take this one and assign it to this. I take type and assign it to this. I take VIN and assign it to this, okay? If I didn't have this, it would be totally meaningless. I was gonna assign type to type again. That means this type will be assigned to itself. Okay, so just to remind you, the difference between single pipe and double pipes that we discussed before, I just wrote this fun example for you. Okay, so this is class test, and this is my main method, okay? Here, the main method. And then I have another method called method, which returns a Boolean, true or false, okay? And I defined a data member, static int x. This is outside the main method, okay? So this class has a static data member x, okay? And then this is the main method. So let's take a look at this. I have if pipe. Remember, if I have single pipe, whether the first statement is true or not, I will always execute the second statement. But if I have double pipes, if the first statement is true, there is no need to execute the second one, because pipe means or. If the first one is true, no matter what the second one is, composite statement will always be true, okay? So here, I start with this method. And first of all, this x is initialized to 0 as soon as the class is loaded, because that's static. Then I will go to this method, okay? What does it do? It increases x by 1. X becomes 1. And what does it return? True. So this is true. But since this is single or, whether the first one is true or not, I will still go and execute the second one. I go back to method and I increase x by 1 again. X becomes what? 2. And it returns true. So this is true as well. Now, true or true. This is true. Because true or true is true. Now this is double pipes. No matter what this is, if the first one is true, second one is totally ineffective. Whether it's true or false, the composite statement is true. Then, since this is double pipes, I will not go and execute this one. I will stop there, and I will get inside this, and I will increase x by 1, 3, and I will print 3, just to remind you. How about if I make this one here double pipes, this one single? First, I'm going to go and execute method. X was 0. And I'm going to go and execute this one. X becomes 1, returns true. So this is true. So this is double. Do I need to go to the rest? No, I'm not going to go there. I'm not going to go there. And I'm going to get inside because true or anything is true, this becomes 2. Okay. How about AND? If you remember, if it is single ampersand, whatever the first one is, you always execute the next one. Okay. So, for example, this is AND. If the first one is false, no matter what the second one is, it's always false, but still, if it is single, you go and execute the second one. Now I'm going to execute method here. X is initially 0. X becomes 1. This returns false. This is false, but since this is single, I will still go and execute this one. I will go right there. X becomes 2. This is false. Since this is single, I will still go there. And X becomes 3. And this is false. False and false is false. I'm not going to get into this. And I'm going to print 3. Well, I hope this is clear, because this was a very important class. And you need to feel extremely comfortable with those concepts before you move to others. You must know what a class is. You must know how to create an object of a class. You must understand some access identifiers. You must understand the new keyword. You should know that you need to make your data private, but yet give a way, a controlled way to access to your data. And you should know about static versus non-static. And we also talk about JOptionPane a little bit. So you need to feel very comfortable with those concepts, but from this point on, we are going to build to more advanced concepts. We're going to go to inheritance, then polymorphism. We'll talk about abstract classes, interfaces. We'll talk about inner classes, nested classes. We'll talk about multi-threaded programming. We'll talk about collections, and we'll talk about some important concepts in Java. So I hope you enjoyed this video, and I hope to see you in the next video.